Welcome to the marking desk. It is 8 a.m. My coffee is black, and my Cambridge digital portal is officially loaded. Right now, I'm looking at my dashboard, and the Scripts Mark Today counter is ticking up, while my mark verification meter is actively waiting to calibrate. Today, we are pulling back the curtain on exactly how Cambridge examiners evaluate your AS and A-level mathematics papers, specifically the notoriously tricky 9709 syllabus, focusing on Argand diagrams and complex numbers. We are moving way beyond the surface level here. I am looking directly for what it takes to hit those core assessment objectives, what the syllabus explicitly calls AO1, AO2, and AO3. By the time we finish this explainer, you are going to know the exact moments an answer climbs into those top-tier marking bands, or tragically drops into the failing thresholds. We're going to treat this like a day in the life at the grading desk, so grab your script and let's get into it. I'm speaking directly from the Principal Examiner reports today to give you an objective, unfiltered perspective on shifting your approach from pure memorization to critical application. Look at this quote on the screen. It highlights a brutal mathematical reality. As an examiner, I can often tell within the very first 15 seconds of scanning a response if a candidate is operating at an A-star tier or if they're slipping down into a C or D tier. The difference, honestly, isn't always raw mathematical brilliance. Usually it's structural execution. It's knowing how to translate abstract principles into the precise framework the assessment demands. Every day, I see two distinct types of candidates. First, there's student alpha. Let's call him Alex. Alex dumps massive, unorganized paragraphs of facts onto the page, forcing me to desperately search for actual analysis. Then, there's student beta. Let's call her Sam. Sam writes with beautiful, elegant flair, but she dances completely around the core command word. When I'm assessing 3.9 complex numbers, my focus is strictly on those distinct cognitive domains: knowledge, application, and analysis. If you're just writing to fill space, you're going to lose those easy marks.
So here is our roadmap for the explainer today. Section 1 is Core Theoretical Foundations. Section 2 is the Procedural Framework. Section 3 is Critical Analysis, and Section 4 covers the top 3 examiner warnings.
Okay, moving right into Section 1, Core Theoretical Foundations. What assessment objectives really mean.
Now, I've got a high-tariff, multi-part past paper question pulled up on my marking interface right now, and it brings up a crucial question. Why is applying concepts to unfamiliar context so incredibly hard for students? Well, it all comes down to how you compartmentalize the syllabus. Let's look at our student alpha, Alex. Alex struggles because he relies on that massive, unorganized data dump. He gives me every single precise definition related to complex numbers, but zero actual analysis. On the flip side, Sam might manipulate the equation seamlessly, but she'll completely miss the core command word. For instance, the prompt specifically asks to evaluate a locus, but Sam simply discusses it. As an examiner, that sentence structural choice is an immediate signal. Discussing is a C-tier approach. Evaluating is an A-tier approach. The syllabus explicitly emphasizes that top-performing students exhibit a connected, conceptual understanding that is transferable. The entire theoretical architecture of Argand diagrams rests heavily on causal relationships and integration with other syllabus areas. It's never just about isolated definitions.
Let me show you exactly what I mean. On the left, we have Alex's standard answer. On the right, the top-tier answer we actually want to see. The difference here is entirely about cross-topic connections. You absolutely cannot just provide isolated definitions for the modulus and the argument line by line and sit back expecting full marks. I cannot award them. You must integrate them. A high-tier response explicitly links the geometric representation, like the locus of a point on the Argand diagram, directly to its algebraic properties. It shows me exactly how the locus dynamically interacts with other complex number constraints. The assessment framework prioritizes this analytical depth over superficial breadth. I need to see logical, structured reasoning that connects the dots across the entire mathematics syllabus. When I see that integration, my digital grading pen is instantly awarding top marks.
Let's move to Section 2, the Procedural Framework, Securing the Method Marks.
Systematic processing within Argand diagrams follows a rigid, standard 5-step sequence. Step 1, identify key elements by deconstructing the question. Step 2, apply relevant principles to select your framework. Step 3, execute the analysis with crystal clear working. Step 4, verify your results. And Step 5, present your answer in the appropriate format. Now imagine a split-screen viewport showing a live recording of our two students, Alex and Sam, actively debating how to write a model response right now. They are clashing hard over structural execution. Alex is stubbornly insisting on listing textbook definitions line by line for Step 1 and Step 2, but Sam is arguing, correctly I might add, that without an evaluative thesis link in Step 3, the examiner is going to severely penalize their script for a total lack of critical depth. They are bouncing ideas back and forth under strict time tracking, editing their paragraph live. And as the examiner watching this, I'm internally cheering for Sam, because mastering this exact 5-step sequence is what secures those vital method marks, even if your final calculation goes slightly off track at the very end.
Let's zoom in on that execution phase. Data interpretation skills are absolutely critical here. If a question gives you a geometric locus description, your first action is to deconstruct it, instantly extracting the exact center and radius. Next, select the correct analytical framework. Maybe you realize you're dealing with a perpendicular bisector scenario. Finally, execute using precise, complex number terminology. Now back to our students, Alex and Sam. They've just hit a massive logical roadblock mid-argument. Their evidence has suddenly stopped supporting their conclusion about the locus intersection. This is where I step in. I deploy the Peel structure: point, evidence, evaluation, link. I show them how to flawlessly reconnect their argument string by stating the mathematical point, providing the algebraic evidence, evaluating the intersection, and linking back to the root question. Perfecting this deconstruct, select, and execute cycle allows you to consistently hit top marking bands under serious clock pressure. Okay, time out for a second. I'm pushing back from my marking desk. Before I grade their final model paragraph and show you the mistake that cost thousands of candidates their A-star, let's secure your own academic trajectory. Hit the subscribe button for Ace the Exams at Ace Exams right now and turn on all notifications. Whether you are sitting for IGCSE, O-levels, AS, or A-levels, this explainer is your direct channel to outsmart the marking desk.
All right, let's get back to it. Section 3, Critical Analysis, Thinking Like an Examiner. I am officially handing my digital grading pen over to you for an interactive live marking audit. Challenge number 1, the 30-second data scan. Imagine a complex Cambridge-Argand diagram showing intersecting loci on screen, with a 60-second visual countdown timer ticking down. You need to extract the single highest yielding trend. If the question requires comparative analysis, you cannot just list features. A weak answer simply states 2 isolated facts. The first diagram shows a circle, the second shows a line. 0 marks. That lacks comparative connectives. A top-band response actively links those concepts. You would extract the trend by explaining that while the first diagram defines a circular locus representing a constant modulus from a fixed point, the second diverges by depicting a linear locus representing a constant argument. You then evaluate how both fundamentally constrain the set of possible complex numbers within that specific domain. That is evaluative thinking. You are justifying decisions with hard mathematical evidence rather than just listing descriptive fluff. Did you spot the trend in time? That's what thinking like an examiner really feels like.
Moving to our final major section, Section 4, Top 3 Examiner Warnings, where marks are lost.
According to the principal examiner reports, there are exactly 3 primary mistakes that continually drag candidates down into failing thresholds on Argand diagram questions. Grab your mental red pens, because this is where dreams of an A-star usually go to die.
Here is challenge number 2 for our live audit. Spot the penalty. I'm putting a flawed sample paragraph from Alex on the board. You need to locate the exact line where a weak link forfeits 5 critical marks. Let's look at the 3 warnings. Warning 1. Confusing cause and effect within complex number relationships. Did Alex mix up whether a change in the algebraic form dictates a geometric shift or vice versa? Warning 2. Forgetting to check the final format. Did the prompt require an answer in polar form, but Alex left it in Cartesian form because he rushed his final review? That bleeds easy marks instantly. But the biggest red flag is warning 3, providing generic answers not specific to the given context. Look closely at Alex's paragraph. Right there, in the 3rd sentence. He dropped a generic textbook definition into a scenario that required evaluating a specific geometric transformation. He ignored the context entirely. 5 marks? Gone. Examiners simply cannot and will not reward generic fluff.
As I take my digital red marker to highlight that flaw on Alex's script, I want you to burn this phrase into your mind. Context is king. Ignoring the unique context of the question and dancing around the core command word is the classic trap. Remember Sam, our student who writes with beautiful flair? I had to deduct marks from her too, because an examiner cannot reward you if your beautifully written answer dances completely around the actual scenario.
To secure top marks, you must ensure your 5-step procedure is visually obvious on the page. Don't waste my time or your time on descriptive fluff. Directly extract the relevant data, execute with clear notation, and always run a final quality review to verify that your format matches the exact command word provided.
Looking back at our live recording, Alex and Sam have finally assembled their completed, flawless response paragraph. They combined Alex's precise knowledge with Sam's evaluative links, perfectly addressing the context. I am highly satisfied to enter a perfect, full-mark score for them into the Cambridge system. To lock this in for yourself, create a mnemonic right now for our 5 procedural steps: identify, apply, execute, verify, present. IAEVP. Build your own personalized cheat code for exam day. As we log off the portal today, I want to distill this session into 3 universal marking truths. Number 1, the 15-second structure scan is real. Make your analytical framework immediately obvious. Number 2, the mark per minute velocity rule dictates you cannot waste time on generic textbook dumps. And number 3, the final quality review pass is where you check your polar versus Cartesian formats. If you want to keep outsmarting the marking desk, subscribe to Ace the Exams at Ace the Exams, click the notification bell for our weekly examiner breakdowns, and leave a comment below right now stating your subject, your qualification level, and your current target grade. Keep analyzing, and I'll see you on the next script.